Well, thank you. It's wonderful to be here with you all today. And I'm happy to represent Xangati in terms of our presentation today, Stop the Virtualization Blame Game. My name is Nathaniel Iverson, and I'm the Vice President of Product Management for Xangati. So it's my job to listen to your feedback and help make sure that we build the right thing. So be sure to stop by afterwards and say hi if there's something that I can do for you. Well, what we want to do is talk a little bit about the challenges that a virtual administrator faces, talk about a few of what we jokingly refer to as the blame wars, and some case studies there. We'll certainly give you a full demonstration, take your questions, and of course, at the end, make sure that you do fill out a survey in the back. There's a gift card giveaway, and you can definitely take yourself through that. It's Xangati's fundamental contention that virtual administrators need to have a complete picture in order to track contention storms. When you have a variety of end user devices, virtual machines, cloud things, storage things, physical servers, network, and dozens of application ports and protocols, it turns out that there's a lot of things that can affect performance. In VDI environments, you could have antivirus updates affecting desktop performance. You could have a load balancer that's not evenly distributing things to presentation servers or to web servers. You could have conversations between a database and a helper application that are split onto different clusters or different hypervisors, or perhaps a slow DNS. We've noticed where people have upgraded a particular application server, and that changed some of the relationships and communications inside the virtual environment. Or perhaps, a WAN congesting things and degrading experience. And with a virtualized infrastructure, any or all of these things could be changing in real time because the infrastructure is dynamic. We also note that performance management of both virtual infrastructure and VDI, by definition, needs to be cross-silo. When you take storage, end user devices, network, and servers, and combine them all together into a dynamic infrastructure, changes can occur literally in real time as DRS and other technologies migrate things around a cluster. And in this environment, it turns out that insights need to come from more than just a vCenter vantage point. There's information within the infrastructure that vCenter doesn't have, and so a comprehensive data center visibility becomes essential. These dynamic interactions are what form the backbone of a virtual implementation. Let's take, for example, some application where you've got a number of backend servers, a data store, maybe some physical servers in the environment, and based on the current conditions, they're configured a certain way. They're running on certain hosts, and users pass through certain infrastructure in order to reach them. Now, if this is time zero, in just 5 minutes, the infrastructure can have changed completely. Some of the virtual machines may be on different hosts. The ESX hosts themselves may be using different paths through the SAN network to connect the virtual machines and the back-end data stores. And so the whole environment can have actually shifted. And if there's been any performance problems during this time, how do you actually know whether it was a change in the infrastructure, a change in the application, a change in the user's behavior that actually created this ripple effect through the environment? And these can, when these events change, the performance storms can come suddenly. We've seen this a number of times actually in our customer base. One time was with a very large clothing retailer, and there was some kind of unintended consequences, if you will, of virtualization. Now, the interesting thing is, I think almost everyone in the room can appreciate that when virtualization is present, sometimes it gets the initial blame, even though it has nothing to do with the problem. And this was certainly one of those problems. In this particular case, there was intermittent performance issues across the virtual network, and it was getting escalated all the way up to their third tier of kind of architect level people. And eventually vCenter would alert, but what would happen is the alert would come on, it would clear 5 minutes later, and there was no warning when it was going to come, and there was no further detail after it had happened. And In this kind of environment, as soon as Xangati was put in, we noticed some very strange network utilization patterns. And it turns out that a particular video server was being overrun with requests to play back a particular video that their CEO had recorded. And it turned out that what had happened is that somebody had recorded the video at the wrong resolution, and it was literally just crushing their WAN. The video was re-recorded or re-output to the right resolution, and all of a sudden, all of the problems went away. So we see that basically dynamic interaction tracking is what's tremendously important. It's not only just metrics that we would call perhaps consumptive metrics, things like CPU utilization or perhaps memory utilization. Those would be things that are consumed, but also actual interactions. Who's talking to what, how long, how many things, over what time period. And this is what enables us fundamentally to understand contention storms. Because these interactions come and go quickly, reports end up averaging out the spikes of activity, whether it's on a data store or perhaps even with memory. And we see these negative interactions that can cross silos. And it's important to have a tool that can actually cross the silo as well and basically display the full context of what's happening for a particular set of interactions. And in this way, it becomes very easy to have cross silo conversations and end some of the finger pointing that can occur between SAN teams, server teams, network teams, so on and so forth. And it's really true that in this kind of brave new world that we have of virtualization, that static relationships and dependencies are really a notion of the past. We saw this at a very large hospital system in the LA area when they virtualized their medical records application. And the project ended up being stalled by 4 weeks. And it's the classic virtualization case of all the lights are green and yet the users are complaining. Particularly problematic was the fact that they had just deployed brand new hardware to virtualize this application, and the only thing on the cluster was the EMR app, and yet the performance was worse than the 3-year-old physical servers. And so, needless to say, the application community was not pleased. What we found was that there was some very large traffic flows going across the internal vSwitches. They weren't hitting the physical network. They were purely across the vSwitches. And Xangati was the only thing that could see these flows. And we said, is it normal for a gigabit of traffic to be going between these two VMs? And we were able to make recordings of the communication and the interaction, which they could then share with the app vendor and say, are these interactions normal? And it turns out that the interactions were not normal. And what happened is that ultimately a patch was made and a bug was found, and it was the ability to share that recording with people in completely different business units that provided the key value. And the source of stall was basically discovered right away. And it's in this environment that, we've noticed that there's a lot of myths that can kind of surround finding performance storms inside of an environment. First of all, the myth that there's a single smoking gun. The reality is that there's often multiple shooters, and you have to be able to see things from multiple vantage point. Another myth would be that it's alerts that really say what's wrong. Something crosses a threshold and bam, there it is. And what alerts do is actually say, well, somebody's already dead. There's already a problem. And what's missing is an interactional context, the equivalent of a motive, or perhaps a video camera that shows you what's going on, as opposed to just a blurb in the paper the next day. Another example from VDI is a place that we actually found backups running during the middle of the day, and there was large traffic going to and from their particular antivirus server in the middle of the business day. And another case, we noticed that data stores were not load balanced. One of the data stores literally 4x the performance of other data stores, and a clear opportunity to distribute some load. Or an antivirus server that is just eating up large amounts of network bandwidth and causing problems other places. And for all of these, really, finding contention storms requires a complete contextual view. And what the Xangati tool does is allows you to place any part of the infrastructure at the center of the universe, if you will. For example, we could place a virtual machine at the center of the universe and understand in context how it connects to physical servers, the network, other virtual machines, cloud resources, end users, storage, and in that way see the whole world from its vantage point. Just as easily, we could go ahead and perhaps take a protocol and put it in the center and understand for desktops how PC over IP protocol performance is affecting the entire environment. Or, just as easily, place storage in the center of the universe and understand exactly how different virtual machines are collapsing onto a single data store, what their interactions are doing to the performance of that data store. So with that, let's go ahead and jump into a brief demo where we can actually see this in action. The Xangati dashboard provides a very quick summary of all of the performance indicators in each of the silos that affect a virtualized deployment or a cloud deployment. And it all summarizes up into a single performance health index at the top. And what you can see is that all of the major silos are represented. Certainly the virtual machines, the hosts that those virtual machines run on, the data stores that sit behind them, the paths that interconnect the hosts and the data stores, the idea of physical servers that may be present in the environment and not virtualized, the virtual networking. Here's the port groups inside the ESX hosts, as well as even router interfaces that may be in the physical environment. And in this way, it's possible to track all the way from virtual machines out through the network to the users and back to see the hosts, the storage, and everything that's together. And what the Xangati system is doing is profiling all of the virtual machines, the hosts, the data stores for their normal activity. It's also combining that with best practice thresholds from VMware and leading bloggers, and combining that into an overall health score that shows what's wrong. And this is what we call our summary view. There is also a more detailed view for some of you that really like your detail. You can actually see for all of the virtual machines, average and maximums for CPU usage, the maximum, so on and so forth. But when there's something wrong inside the environment, finding out what it is a very simple matter of using the system and a very quick workflow to see what's going on. First of all, the Xangati system, you will notice, is operating in real time. It's accurate to the second. And you can see that there's a lot going on in the environment, and we can even grab the slider bar and actually rewind time to see how the environment was different at different points in time. One of the unique things that Xangati does is place all information onto a synchronized timeline. So it doesn't matter whether it's network information, hypervisor information, storage information. We synchronize it all to a single timeline so it can get the complete context of how things interact over time. Let's take a look at how this works by clicking on one of these alerts. And we can see that currently there's a host alert. Maybe we'll go ahead and look at all the alerts that are currently present in the system. And we can see that there's host alerts and data store alerts, CPU usage alerts, so on and so forth. Perhaps we would be interested in this data store alert. When we double click on the data store alert, we're taken not just to a description of a static threshold that says, hey, it went over by a certain amount, but we're actually taken to a recording. And this recording preserves all of the 1 second data that we're getting from the network. It preserves all of the 20-second data that's available from vCenter and places it into a user interface that allows us to see contextually exactly what's going on. First of all, we can see that, yes, we do indeed get to the causality that there's, something going on with this data store. But we can also notice that there's a particular VM in this that's attached to this data store that is also in alert. And it looks like this particular data store is doing a lot more IOPS than it normally does. And we can go ahead and grab the slider bar in this recording and basically see how the latency is affected over time. Now, in this particular case, the IOPS load is doing its thing, and it looks like that it was right here in the very beginning of this particular point of time that there's a big burst here to 500 milliseconds of data store latency. And if we wanted to, we could go ahead and pause it right now and basically notice that, yes, indeed, there was a huge amount of data store latency. At this particular point in time, it looks like the traffic is coming from a single host with really one virtual machine that's driving that. And it happens that this particular virtual machine, its access to my very old and slow iSCSI SCSI machine is actually causing problems for the other things that are affected, particularly this view manager server is basically getting dumped on. It's not doing any particular amount of load, but the load that this one is producing is basically causing contention that can affect it. And so you can see very quickly that Xangati offers an ability to get directly to what the root cause is of a particular issue. The Xangati system excels at operational troubleshooting, at finding out what's wrong in an environment, but also provides a very strong monitoring capability that allows you to see exactly what's happening in real time. I've shown you the dashboard and this ability to look very quickly at summary metrics, perhaps like IOPS or CPU, memory, things like that. But it's also possible to drill in for a closer look using the monitor. Using the monitor, all of the tabs of the dashboard basically appear here on the left, and you can see all of the virtual machines in my environment, and we could sort them, for example, by CPU usage, and see exactly what's happening with groups of virtual machines. We could look, for example, at perhaps a virtual desktop like the one that I'm using to actually give you this demonstration this morning. And we could drill in to a particular item and it'll populate with exactly what this particular item is doing. We could look at a protocol, for example, like NFS. Here's all of the things that are using NFS inside my environment. And I can skinny this up a little bit, and we can see what the total NFS bit rate is, the number of things using NFS, so on and so forth, even which interfaces the traffic is flowing across. And if we wanted to, we could go ahead and drill into any of these items, whether it's an ESX host. We could jump from the ESX host to a particular desktop that might be an alert, and we can see that it's having memory usage. And we might be curious, why is there memory usage problem on this particular desktop? And so we could go ahead and drill into the Windows system using WMI. One of the tools that our system has is the ability to use the Windows management interface to drill in and actually get all of the process information for memory and CPU from any Windows machine. And this works whether it's a server, whether it's a desktop, or some kind of ancillary, system that is providing help. And so what the system does is it goes ahead, logs into the desktop, and then gets all of the information onto at the same timeline, because at this point our system knows a lot of information about this particular virtual machine. First of all, we can know what its network connectivity is doing. We can see what its CPU and memory and hypervisor usage is from vCenter, and then we are also going to combine that with information that comes directly out of the guest to provide us a full capability to see what's going on. This process normally takes about a minute, mostly due to the fact that it takes about 30 seconds just for Windows to log us in. The beautiful thing is that when the processes by memory and CPU usage come up, we can actually record all of this information using the red record button. Now we're able to go ahead and do that manually by saying now, or schedule it for later, which can be great if you've got intermittent problems where you need to just record what's happening on the second floor or something like that. So this record capability is powerful because it allows you to preserve all of this data and basically share it with somebody else. And so we can see exactly which processes are consuming memory on the server, and it might be that using this we would be able to see that some particular process has run away with memory, or perhaps it's we've got a stuck web application where Java is consuming all the CPU or something like that. And so these viewers provide a very rich capability to understand exactly what's going on inside of a particular system. And you can see, just as I maneuver around, it's very possible to click on almost anything and instantly reorient the entire world to the perspective of now an NFS data store. And so you can see that just with a couple clicks, we've looked at a protocol, we've looked inside a desktop, a host, a virtual machine. We've gone ahead and looked at a data store and all of its connectivity to the world. And so Xangati provides an ideal complement to sit alongside a configuration tool like vCenter and provide a very rich set of performance metrics that just are instantly changing and provide you complete contextual details to exactly how all of the communication is taking place inside the virtual environment. The Xangati system also provides a full capacity management system that enables you to look at trends and actually see how these things may affect the future, to deal with historical reporting, and even to pull the profile information out directly if it's useful for manual efforts to look at how overall performance is going. So the Xangati system is really one that is designed specifically to take a look at the entire environment to map out where contention and performance storms are occurring and illuminate those so that you can directly address them and provide some very rich capabilities of reporting and real-time management to basically share with other people so that you can get your heads together and actually get things resolved. So with that, we should go ahead and jump back to a Q&A session, and I'll certainly be happy to take your questions, and we can go from there. Thank you so much for your attention.